everyone, my name is Azbek Anvarov, and in this video we're going to talk about random variables and probability distributions. And I'm going to help to assist my AI assistant, and he's going to teach you some of it. So here we go.
And I'm going to help you learn what random variables are and what they do. I will also explain discrete and continuous random variables. In simple terms, a random variable is the result of a chance event that you can measure or count. For example, in our probability videos, we looked at the probability of getting a lunch with an apple and a banana cake. This was the result of a chance event, but it was not a random variable as it was not a number. We will use the following example to learn about things that are random variables. Luke has an ice cream stand and sells hand-scooped homemade ice creams in cones. Luke wishes to analyse his sales and make decisions about employing an assistant and expanding his business. Luke has collected data from the last month and can tell you how many ice creams were bought in each transaction. The table lists the number of ice creams bought and the number of customers who bought that number of ice creams. We can define X as being the number of ice creams a customer orders. X is a random variable. It is called random because it can take several different values and is the result of a chance happening. We estimate the probability for each value of X by finding the relative frequencies from the historic or experimental data. The distribution for X, the number of ice creams one customer buys, looks like this. As a dot diagram, it looks like this, which could be rearranged to look like this. We often like to show distributions as a graph. We can use this distribution to answer questions. Luke wants to know what is the probability that the next customer will buy exactly one ice cream. We look on the table and tell him that the probability that x equals 1 equals 0.45 or 45%. Luke then asks, out of 200 customers, how many would we expect to buy more than 3 ice creams? We want to find the probability that x is greater than 3, so we add up all the probabilities that apply. The probability that x is greater than 3 equals the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6, which equals 0.04 plus 0.04 plus 0.02, which equals 0.1 or 10%. 0.1 times 200 equals 20. So we would expect 20 customers out of the next 200 to buy more than 3 ice creams. This example of number of ice creams is an example of a discrete distribution, as you can only get whole numbers of ice creams. Other things that can be modelled as discrete random variables are number of customers who arrive in the next hour, number of customers who pay by cash, number of days in a month in which the stall is closed due to rain, number of cones that break while being filled. The following cannot be modelled as discrete random variables because they cannot be counted. The flavour topping a customer chooses, the ethnicity of the customer, the method the customer uses to pay. Some random variables are continuous, which means that they can take any value within a range, including fractions. If we wish to model the weight of an ice cream, it would take a range of values in grams, so it would be modelled by a continuous random variable. Luke is interested in how long he takes to serve a customer and how long to scoop an ice cream. These would both be continuous random variables measured in minutes or seconds. For each of the following, decide whether they would be modelled as a discrete random variable, a continuous random variable, or not a random variable. Weight of a suitcase, number of emergency calls in an hour, marital status, time taken to get to a fire, length of a tulip stem, colour of a tulip flower, number of bulbs that produce flowers. You can see the answers at the end of the video.
So thank you for you, and now we can check the answers. The first one is the weight of a suitcase. so it is obvious continuous. The next one is a number of emergency calls in hour. It's a countable whole number, that's why it's discrete. Next one is a Marshall status. It's a categorical data, so it's not a random variable. Next one is a time taken to get to a fire. It's a measurement of time that can take any value, so it is a continuous. Next is a length of the tulip stem. It's a measurement of length that can take any value. It's also a continuous. Next is a color of tulip flower. So it's a categorical data, red, yellow, just like this. So it's not a random variable. Last one is a number of bulbs that produce flowers. It's a countable whole number, that's why it's discrete. Thank you for watching this video. Goodbye.